you all for joining us for today's SQL Server Series webcast, exploring the new Hadoop implementation in Azure presented by Jacob Saunders. My name is Amy Nelson, and I'm the Marketing Coordinator for Neudesic and the moderator for today's webcast. This webcast is presented by Jacob Saunders, Neudesic's Practice Director of the Business Intelligence Practice. We are very excited to have him present for us this morning. Today's webcast is part of our SQL Server Series. We will be hosting the next webcast, Data Integration Improvements within SQL 2012, on July 24th. We will be sending out more information about this webcast along with today's recording. If you are logged on, you should all be able to see the title slide that states Neudesic. There was a brief intro earlier regarding features within Live Meeting. To briefly recap, we encourage you to ask questions throughout the session by typing them in. To ask a question, click on the Q&A verbiage located in the toolbar on the top left side of your screen. Type your question, then click the Ask button. Please note that all questions will be held until the end. We will also be using the seating chart feature within Live Meeting. Changing your feedback color within this tool provides feedback to the presenter. To provide feedback, click on the feedback menu found in the upper right-hand corner of your screen. Select your feedback color. Your seat in the conference center will display your selected color. Lastly, this webcast is being recorded and will be available via the Neudesic website. We will email you when the link is available. If everyone is ready, please make sure your seat color is green. And at this time, I'd like to turn our presentation over to Jacob.
Hi, everybody. Good afternoon from Chicago, and whatever time of day it is for you. Thank you for joining us today to talk a little bit about Hadoop and specifically the implementation of Hadoop on Azure. First of all, I'll note that I'm by no means a Hadoop or big data expert. I took the opportunity to do this webcast and spend a couple weeks diving into the technology, learning as much as I could. Found it to be a compelling and interesting technology, a really easy implementation on top of the Microsoft platform, and hopefully you guys will learn something from today's webcast as well. So the agenda for this webcast, we're going to talk a little bit about what Hadoop is, some of the background, how it came to be. Talk about the major components of Hadoop, which are the core components are HDFS, so the Hadoop Distributed File System, and MapReduce. Talk a little bit about what the next steps are for the platform, since it's fairly young and it's still under development, and share some resources with you guys. Now, there are a couple slides with links at the end of this. I think Amy will provide a PDF of the slide deck we're using today so that you can review those at your leisure. And then we're going to go into a live demo, show off some of the capabilities of Hadoop around text file analysis, its behavior as a columnar database, and look at some of the integration points with other systems.
Hey, Jacob, real quick. You're not sharing your slides. Can you go ahead and go up to Content and Share?
Okay. All right, how's that?
Perfect. There we go. Okay.
Sorry about that. So first of all, what is Hadoop? So as one of the engineers at LinkedIn put it, pretty eloquently summed it up, a system for processing mind-bogglingly large amounts of data in an efficient manner. You'll notice that this guy works at LinkedIn, and they are a heavy user of this technology. So in plain English, Hadoop is based on a large-scale distributive storage, so storage that's spread across nodes. We'll get into that a little bit when we start looking at HDFS in a minute. It is definitely not a relational database, although it can behave as a columnar database. It was designed to process large amounts of complex data in an efficient manner. Is really good at organizing unstructured data and performing analysis of textual or other unstructured data types. It's an open source tool maintained by the Apache Software Foundation, and of course contributed to by many of the firms that are using the technology. So brief history of Hadoop came out of Google. You know, obviously Google has needs to store and perform analysis on vast quantities of data, basically the entire contents of the internet. So a couple of Google engineers wrote two papers, one about the Google file system and another one about their MapReduce concept. And the Hadoop implementation basically came out of those two papers. Was initially written as part of an open source search engine by a man named Doug Cutting, who also named the tool. And that open source project was Nutch, which formed the genesis of Hadoop. Some of the concepts in Hadoop, though, are not necessarily new. So one of the things that we'll look at when we talk about MapReduce is the concept of problem partitioning, and that's as old as Lisp and other procedural languages. Yahoo was involved early on with Hadoop, and actually is the primary contributor today. So they use it heavily and also contribute significantly to the code base. They actually brought Doug Cutting on board, who was the inventor of Hadoop. But why is it called Hadoop? It was named after Doug Cutting's son's toy elephant. So it's a meaningless word, but hence the name and the logo. So looking at a couple of the companies that are using Hadoop today, some big names here: Adobe, Orbitz, New York Times. So large content providers, large retailers, large social media companies like LinkedIn and Twitter and eHarmony. Rackspace, a provider of hosting services, etc., and Microsoft, of course. So the two main components of Hadoop are the file system, the HDFS, which provides the storage engine for Hadoop, and then an open source implementation of the MapReduce concept. So MapReduce isn't a brand name. It denotes a two-step problem-solving process, initial mapping process, and then a reduction process, and that forms the map and computation engine of the solution. So before we go into more detail, it makes sense to show this little architecture slide that shows how the ecosystem fits together. So at the core is HDFS, the file system. On top of that is HBase, a columnar database. That one is implemented in the Linux version of Hadoop and is not yet part of Hadoop on Azure. So HBase won't be available for some time, if at all, on the Microsoft platform. Then there's the MapReduce engine, which takes care of job scheduling, execution, batch processing, and a couple things that sit on top of that that make it a little easier to use. So there's an ETL tool called Peggle, which is basically a data flow programming environment. For those of you familiar with SSIS, Peggle is a text-based version of the same thing. So it performs sequential processing of data sets, and every time you execute a command against it, a new data set is generated that you can then use for further downstream processing. There's also a data warehouse called Hive that functions a little bit more like a tabular relational database that you're used to seeing, and has the ability to connect to a variety of BI tools, including Excel, Power View, and the other Microsoft tools. And then there's a tool called Scoop, which is an integration tool that is able to pump data in and out of Hadoop to and from relational database engines. And we'll be looking at Peggle, Hive, and Scoop as part of the demo today. And there are a couple of other tools for task management and serialization. So there's Zookeeper and Avro. We're not going to dive into those today, but they help complex job processing and other functions on the platform. So what is HDFS? It's a distributed file system, runs on large clusters of servers. Those are also referred to as nodes. So the ability to spread out data over vast arrays of commodity hardware. The file system itself looks exactly like Unix. So if you're familiar at all with Unix or Linux file system commands, you'll find Hadoop to be pretty intuitive. Most of the common commands like ls and cat, make, dir, all that stuff are available. This is an example. I don't know if this is readable for anybody, but if you type in help on the command line, you'll get a little command reference that shows a bunch of very familiar looking commands here. So what are the benefits of HDFS? Well, it can read incredibly large files in the petabyte and exabyte range. Now I'm a data guy, but even I have problems trying to visualize an exabyte. So it's a billion gigabytes, and there's not a whole lot that we can compare to it. It's been said that every word uttered by any human that's ever been alive would add up to about 5 exabytes. So we'll try to add a couple of kilobytes to that today. So HDFS takes an incoming file and splits it up into configurable blocks, file blocks. So the default size is 128 megabytes, but that can be tuned and adjusted as needed. Per default, it makes 3 copies of each block. So there's some redundancy in there, and some parallels and already inherent in the file system itself. That number can be configurable as well, based on how much money you want to spend on storage. So how does HDFS store the data? As I said earlier, incoming data is broken up into chunks and is stored in data nodes that are part of the cluster. And the data node is just an individual server within a Hadoop cluster. There's one node that does not store data, known as the name node or the head node. And it keeps track of where all of the blocks are mapped on the other servers. And so another interesting thing to call out here is that some implementations of Hadoop have data-aware HDFS. So the name node or head node actually keeps track of where individual records are stored. In the current implementation of Hadoop on Azure, HDFS is not data aware, so it's able to keep track where a particular block of data resides, but not of the individual records within that. And I think that may have something to do with the fact that HBase hasn't, the fact that HBase hasn't been implemented yet may have something to do with that. So the other major component of Hadoop that sits on top of the distributed file system is MapReduce. As the name implies, it consists of 2 parts. So the map function takes a large data set and partitions it into several smaller data sets, and partitions your problem as well, so that any query that you execute can be spread across the nodes in the cluster, which is how Hadoop is able to so efficiently parallelize and process these huge amounts of data. The reduce function then takes the output of each one of those map functions and performs aggregation logic on those. So what is it good for? Sorting, statistical analysis on large data sets. Anything that requires parallel processing of massive amounts of data, mostly for analysis purposes. So obviously it's not something that's suitable to a transactional environment. So how does it work? Everything in MapReduce is treated as a key value pair. Whether that's a word and a numerical count of it, or some other combination of keys and values in a textual format. So to write a MapReduce, the first thing you do is write a mapper that takes a key and a value and emits 0 or more keys and values as its output. And then you develop a reducer that takes all of the values for one key and emits 0 or more new keys and values based on that. So that's that second aggregation step. So what does this look like? Well, the very first step in a mapper, say we're analyzing this sentence from the Gettysburg Address. It'll turn it into a key and a value pair. Key is not used in the count at this point in time, and we'll see how we put this through the reduce process and come up with a tallied list of word frequencies here. So each individual mapper is now handed a key and a value as well, and as they go through and process that, they'll in this particular example, we're breaking the sentence out into individual words, and each one of those words is given a 1 tally on that given node, which is wherever that particular data block resides, and so that assignment of those pieces of mapping logic is handled by the name node or head node. So now that we have our individual lists from each one of the nodes with a tally of 1 next to each value, the next step is to take this output, which is basically a giant list of single individual values, perform a shuffle function, so taking duplicate values and starting the tally process here, and coming up with an aggregation that shows how often each word occurs, and that's the reduce process that takes that all of those individual mapper outputs and shuffles them and turns them into a list like this that counts occurrences in this example. So, it's a great technology. It's useful for a lot of different scenarios, but it doesn't always map to your business problem. So going back into that ecosystem, there, a number of the tools that sit on top of Hadoop stop you from forcing your problem into that key value pair paradigm. So Pig, as mentioned before, is a data flow language, also an execution environment that allows you to explore these huge data sets and that generates map and reduce functions on the back end. Hive, which is a distributed data warehouse, it can either hold its own tables or it can link directly to data that's already in HDFS. And the runtime engine takes very familiar looking SQL and converts that into MapReduce jobs for analyzing that. HBase, again, we talked about that a little bit, not available in Hadoop on Azure. And then Zookeeper, the coordination service, allows for distributed locks that would allow you to actually build applications on top of Hadoop and lock into individual records, as you would in a traditional database environment. And then Scoop, which is the kind of the data pump in and out of Hadoop that we'll look at in a minute. So what's next? It's interesting. Right now, Hadoop is seeing tremendous adoption in the marketplace. A lot of as we saw on the list of companies that are using this, a lot of large organizations are kind of turning Hadoop into the de facto standard for big data analysis and storage. But there are a couple of shortcomings, and so Google has already started moving beyond GFS and MapReduce and has developed some really interesting tools that hopefully will make their way into the Hadoop ecosystem as well. So one of those is Percolator. So you can, once Hadoop is up and running on a large data set, it's incredibly efficient at crunching that data. But if data is flowing into that constantly, analysis tasks start to take longer and longer as you add data to that. So Percolator is an incremental indexing tool that works only with new, changed, or deleted information, and uses a set of secondary indices to catalog and query that output. So, on a rapidly changing data set, the performance gains are absolutely huge using Percolator. Another thing that MapReduce is not necessarily good at is ad hoc data exploration. So kind of self-service BI or ad hoc query scenarios. It's great for executing pre-planned jobs to analyze and aggregate data, but to allow ad hoc BI and ad hoc querying on top of it, there's a tool called Dremel, which is now been productized as BigQuery, that allow analysts to scan through petabytes of data and generate output for visualization tools. Another thing that MapReduce is not great at is analyzing graph data. So doing things like calculating the single shortest path between 2 points in a graph would require you to continue to pass output through MapReduce in an iterative fashion, which is incredibly inefficient. So a tool called Peggle has been developed and helps with Hadoop implementations where the goal is to analyze multi-node networks, so relationships between people, network diagrams of telecommunications equipment, links between documents and other graph structures. Another really cool thing, I know a lot of SQL Server developers have been migrating towards LINQ, kind of a much more modern implementation of a query language. I mean, we've been using SQL for 40 years or so now, and it's showing its age a little bit. So LINQ has become increasingly popular, especially amongst .NET programmers, and Microsoft was originally working on a tool called Dryad LINQ that would connect LINQ to HPC, and has refocused those efforts in order to develop a LINQ to Hadoop interface and allow LINQ queries to be transmitted to a Hadoop server and translated to MapReduce functions. So I think once that comes out, you'll see a huge uptick in adoption amongst the developer community that right now may be struggling with the best way to leverage Hadoop within their applications. So some of the resources that I used and some handy language references, etc., are on these next two slides. We don't need to talk about them. As I mentioned earlier, Amy is going to be providing this deck to you all in the form of a PDF, so feel free to read through those at your leisure. So I'd like to go right into the interactive demo. Hopefully, I'll be able to successfully convey some of the power of the features of Hadoop. I'm going to start off by talking about different ways to access Azure Hadoop. So there are a couple different ways that you can get into the system and interact with it, and I'll show you a variety of those. Demonstrate the process of loading files from the local NTFS file system into HDFS. We're going to look at running some pig commands in line from the interactive console, as well as running a custom JavaScript file that's going to do some word identification for us. Also going to look at Hive. So we'll build a Hive table on top of some of our output from this. Look at connecting to that from Excel and potentially also Power Pivot or Power View or any other of the Microsoft kind of top layer analytics tools. And we'll look at Scoop and specifically we'll look at integrating a Hadoop instance with a SQL Azure instance and look at what the process of moving data back and forth between those looks like. So with that, I'm going to exit out of my deck. So when you first connect to your Hadoop instance, you get kind of a nice sort of Metro-y live tile type interface. When you create a Hadoop instance for default, it's available for 4 days. Right now, all of this technology is still in preview. Next logical question is can I get it? The answer is probably yes, depending on the firm you work for. So right now, there's a survey on the Microsoft site that you can go and complete, and if they decide to let you join the preview program, you'll get an invitation to join the Hadoop Azure preview, and you'll be able to spin up as many clusters as you'd like, different sizes. There's some great demos and other examples that are part of this, and you'll be able to walk through different uses of the system. So, talking about different ways to connect to the system. So there's the three main ways are the interactive console, and there's an interactive console for JavaScript and also one for Hive. Remote desktop connection, and also the ability to connect via FTP and ODBC and other tools that are directly accessing the cluster. So to jump into remote desktop, and you'll have to bear with me for a second while I reorganize my windows a little bit here. You can tell that you're connecting to a completely standard Windows machine. So Hadoop on Azure is actually running on Windows. There's no Linux weirdness behind this. So there are different ways to get files onto this system. In this case, I just used Dropbox. So I've got a variety of text files here that are sitting on the NTFS file system and that we're going to be working with today. And as soon as we go back to Hadoop, I'll show what the process is for getting those into HDFS. So I'm back on my Hadoop cluster here. Let's go into the interactive console and get started. So I had, there's a couple different ways to upload files. As I mentioned before, I've already dropped mine onto the file system, so I'll just be able to copy them into HDFS. Another one that's of note is fs.put. So if you execute that. Okay, that didn't work. Okay, so well, you'll have to believe me. There's an fs.put function. I believe I'm typing it the wrong way, but it basically opens a little upload dialog box that allows you to choose a file from your local computer and upload it there. I think there are some size limitations on there. I'm not sure what they are. They appear to be changing over time, but I found it easier to go directly to the file system. So I'm going to execute the copy from local command a couple times here to get the 3 files that we're going to be working with today into HDFS. So it's a really simple command. I've just got the local path here and my target path on HDFS. So I'm going to move in a couple of text files. And then a custom JavaScript file that we're going to be looking at shortly. It would help if I copied that first. So yeah, using the cat command, again, familiar to Unix and Linux users. I'm looking at a very simple little file here. So all this is doing is outlining a map function and a reduce function, and doing some word identification, so I can do a word frequency count. So we're going to be executing this as part of a MapReduce job. So I'm going to paste in a command here that we'll walk through. So I'm doing executing a pig command to create a MapReduce job. My input file here is a file with some social media posts from our internal social media application called Pulse. Check it out on the Neudesic site. It's an incredibly powerful collaboration tool for organizations internally. You'll also notice as I go through this command that it's structured very much like LINQ. So I'm doing a from and then a MapReduce, but it's a hierarchical command set. I'm passing in my JavaScript file here. I've got my order by clause. I'm grabbing 100 top records, and I've got an output file here. So basically, what I'm doing is I'm taking a fairly large number of posts. We're not analyzing exabytes of data today. Obviously, I had to pick something that would run relatively quickly during a demo. So we've got a file with 28,000 posts of various lengths from our social media tool, and I'm going to do a word frequency count there, and then grab the 100 most frequently used words. And I will also add as an addendum to the presentation that Amy's going to be sending out a list of the commands that I used today. So I'm going to kick this off. It's generating a log here. It's pretty verbose, so it helps a lot with troubleshooting. You'll notice we kick this off at 5:32 on whatever time it is on that server. This is probably going to take about 3 minutes to process. So while we let this run, I'm going to go back and walk through some of the examples that exist. So the word count that we're going to be doing builds on one of these examples, but we're going to do a little bit more with it than they do in the sample here. Another cool way of accessing Hadoop is C# streaming. So it's a way to integrate Hadoop into your .NET applications. Unfortunately, it doesn't take advantage of all of the parallelization and performance features that Hadoop has. So I think in most real-world cases that's probably going to be replaced by link to Hadoop when it becomes available. There's also a nice example of a 10 gigabyte sort. It will run much faster than you would expect that to run on a traditional RDBMS. And a couple of other examples here, so including Scoop. So I would definitely encourage you to go through and walk through these one by one to really dive into the platform and understand what all its capabilities are. So let's check on our job here. You'll see that it's performed its entire mapping process. It's also performed its entire reducing process of those words. So hopefully it'll run a little quicker than it did earlier for me today. Another thing of note is the job history here. So as I execute jobs against this server, there's a nice little log of those here. You can download them. You can also go into the individual log files and look at what went wrong, for example, in this job. So a pretty friendly interface for managing all of this. And another thing worth noting is that when you go into this website and provision a cluster, all of the installation work is done for you. So installing Hadoop on a Linux implementation is no cakewalk. That's a multi-day process. A lot of text configuration, a lot of compiling stuff yourself. Once you've put in the name of your cluster here and a username and password, and you click generate, as expected of Microsoft, you just kick back, and about 15 minutes later, you'll have a fully functional Hadoop cluster available, including installations of Hive and Pig, and a number of add-ons that you would need to deploy yourself if you were installing to Linux. So, look at our job here. It's probably going to run for another minute or so. So, meanwhile, let's look at SQL Azure for a second. So, I've got a SQL Azure implementation here. I'm doing a select start from systables. You'll notice that there are no tables available here. I'm going to create a table on here that we're going to use later when we demo Scoop and move some of our top 100 words data in here so that we can analyze it in Excel. I'm going to create a really simple table here. All it has is the word in question and an account of that word. I know I'm using a protected keyword here. Not best practice, but it'll do for the purpose of the demo. Then another important thing is that there has to be a clustered index on every table for SQL Azure to be able to manage that properly. So SQL Azure does not like unindexed tables, so we're going to take care of that. As you can see by the success statement down here, our table's created. I'm going to hit a select star, so I'm proving that it's empty here. There's zero rows returned. So it looks like in the meantime, our MapReduce job there to do our top 100 words has completed. So let's take a look at some of that data. So as I mentioned, Pig generates successive data sets. So now I've got my output data set, and I can go ahead and do a file system.read to pull that in. you'll see a list of top 100 posts here. Now, obviously, if we were doing this in a real world environment, we'd be filtering out things like the and to. But you'll notice that .coms are mentioned frequently, and obviously our own company name is mentioned a number of times. Microsoft as an important partner is mentioned a number of times. So if you were to, sorry about that. So if you were to filter out some kind of common dictionary words here and everything like that, it would be very easy to come up with a pretty valuable analysis and generate some tag clouds around what people are talking about within your organization. Another cool feature is the ability to parse and then graph this data. So if I pull this in, now you can see that it's generating a ranking here. And I'm going to generate a graph that is not going to look particularly informative because of the large number of words we chose. We picked 100, so they're a little hard to read here on the bottom. But some kind of neat graphing capabilities built in. Ability to do a lot with that data. Now, what we've just done is show off the ability to handle unstructured data. So we've basically gone through a very large text file and done some word frequencies. Pig is also able to treat that data as columnar. So let's look at some of the capabilities to do grouping and create schemas and treat this data as you would in a traditional database. I'm going to go here and I'm going to define my schema. So I've got a file that has the individual that created the post, the pulse itself, the year, the month, and the day that was created. So I'm going to go into Pig and define that schema. And now I'm going to do a grouped query here. So again, very link-like. So I've got my from statement here using this schema. I'm going to look only at posts from 2011, and we're going to group them by the individual that created that post. This should go somewhat more quickly. Should be ready in a couple seconds. Now again, Hadoop on Azure, it's great as far as a proof of concept and familiarizing yourself with the technology. That said, the type of performance that you get out of these these kind of end user free clusters is not necessarily what you would expect if you if you had this stuff running in a massively parallel environment in your on your own hardware. So don't be too disconcerted by the processing times that we're looking at now versus the number of records. That said, there is a 10 gigabyte example out there that processes pretty quickly. And if you're really brave, you could deploy a Linux cluster on your own hardware and start doing some real benchmarking. So you'll see the system has now gone through and grouped my posts for 2011 by people. So if I look at that, we'll see the frequency with which certain folks posted within that time period. So now that we have our top 100 words, let's take a look at importing that into Hive and show what that would look like in a more familiar SQL kind of based environment. So there's also a Hive console. Go through and I need to create a table here. And so interestingly, there are a couple different options in Hive. One of the things you can do is create an external table, or create a table that pulls in data from HDFS and stores it in Hive. But in this case, I'm creating an external or linked table here to point to my top 100 words from Pulse. And I'm pointing here at an existing HDFS location. So this is the file that we just generated. So go through, and it'll take a couple seconds here, and it says that it's successfully linked to this table. So now suddenly we can start executing some more familiar commands against this. So if I want to do now Hive is actually going to translate that into a MapReduce command, and it should return my list of top 100 words here shortly. Uh-oh. I believe I still had a table keyword in there. Let's see what this is. Oh, yes. That's what I get for copying and pasting. Okay. And you'll see that I've translated my command to MapReduce and pulled back my my most common words here with their frequencies. So this interface here is fairly limited. It's clear that you can execute some simple SQL commands. But let's look at connecting another tool to that. So we'll go into Excel. There's an Excel add-in for Hive. You can download it for free. And what it adds is a little Hive pane button here when you go under your Data tab of Excel 2010. I'm going to click on that. And I am going to connect to that Hive server that we were just looking at, and do some querying against my top 100 words list there. So it'll connect here, and then I should get a drop-down list with my object. So we just created this Pulse top 100 words list. I'm going to select that, take both of my columns, and there's some aggregate grouping and other stuff you can do here because we're already looking at an aggregate data set. I'm just going to pull it in the way it is, but we are going to order it by the count. That's not good. Looks like it's actually doing this time. That's that darn Unix. I think my username was case sensitive there. That's not familiar to us Unix or to us Windows nerds. Bear with me a second. It should be pulling this into Excel. And again, you can build whatever you want to on top of this. So you could build a Power Pivot where you're integrating some of this stuff with tabular data from other sources. And build some kind of rich and interactive visualizations on top of this. And so here you'll see that it pulled my word list from Hive into Excel. So Excel connected to Hive. Hive converted my query again into a MapReduce function. And here's my list of words I can work with. So some pretty great connectivity to other platforms. One of the other things I want to show you is Scoop. So we'll dive into that now. So you'll remember that a couple minutes ago while we were waiting for our first job to execute, I went into my SQL Azure instance here, and I created a table. It's now empty to store again those words and counts. And if you're interested in experimenting with this, there's a 90-day free trial open to everyone, so you don't have to go through a questionnaire or an invitation or anything like that. As you do for Hadoop, 90-day fully functional free trial is available to the public. So in order to run so Scoop is a command line utility that runs on the head node of your Hadoop cluster. So we're going to go back into this machine. We're going to kick off a Hadoop command shell. And then we're going to execute this command, which is less daunting than it looks like. So we're just kicking off Scoop. We're telling it to export. We're connecting to this long string here, which is the connection string to my SQL Azure instance, defining the table that we're going to be loading into, and the export directory in HDFS that we're pulling this data from. And then figuring out this /T, again, as a Windows guy, it took me about an hour on Sunday to figure out that was a new line, but was a tab character. You may have to experiment a little bit to get this stuff working, and especially these command line utilities sometimes require a little bit of research. But everything seems to be working great, and it's a really powerful set of tools. I'm going to kick this off. I've got an error message here saying that my file already exists, but that's okay. I'm doing the same thing as last time. And again, you'll notice that every single tool that runs on Hadoop, however user-friendly it is, or conceptually however it exposes that data, in the end, it's always creating a MapReduce function. So that is the computation engine on Hadoop. So we'll see here, we exported 100 records. So if I now go back into my SQL Azure implementation, and I hit run. Now I've got my word list in Azure, and it's just as easy in the other direction as well. So this functionality to export to Azure is actually fairly new. The first Hadoop to Azure or Scoop to Azure connector only worked one way for loading data into Hadoop, but that communication is bidirectional now. So you can build any kind of integration points with your existing cloud apps that you'd like to. So that brings me to the end of the demo. Amy, I'm going to give the floor back to you.
Great. Thank you, Jacob, for that awesome presentation. If anyone has any questions, please go ahead and type them in at this time. To ask a question, please click on the Q&A verbiage located in the toolbar at the top left side of your screen. Type in your question, and then click the Ask button. In the meantime, I'm going to click through a few polling questions, and we would greatly appreciate your feedback. The first question, was this content helpful for your business, yes or no? Great, thank you. The next question, please rate the presentation content, excellent, good, or poor. Great, and the last question, Would you like us to schedule a follow-up? Yes or no? We will be forwarding a link to view a recording of this webcast once it becomes available. Again, thank you so much for everyone for joining us, and we look forward to seeing you on our next webcast. You are now free to disconnect.
Thanks, everybody.
Thank you.